Hey guys, it's Mrs. Boulanger here. So what we're going to look at today is how to solve quadratic equations using the formula. So previously we have solved quadratic equations, found the zeros by factoring, and we also looked at how to solve quadratic equations by graphing. So graphing your parabola, finding where it crosses the x-axis, or finding your zeros. So we're going to continue the same theme today, but we're going to be using the quadratic formula, which is this guy right here. So x is equal to negative b plus or minus the square root of b squared minus 4ac. That's all under your square root sign, and the whole thing's divided by 2a. We are going to look at where this formula comes from. It's a little bit complicated, and it has to do with completing the squares. So I can't explain that to you, where it comes from, until we complete the square. But once we do that, we'll revisit where this guy comes from. I didn't just make it up, I promise. Okay, so we can only use the quadratic formula for quadratic equations that are in standard form, or in other words, we don't have any brackets. So ax squared plus bx plus c is the typical form. We've got our quadratic term, our linear term, and our constant term, and it has to be set equal to 0. Just like when we solve by factoring, we have to make sure that equation is equal to 0. So you might be asking yourself right now, why the heck did Mrs. Boulanger make us learn how to factor? And why did we have to solve by factoring? So there's a couple reasons. One, if the quadratic equation is already in factored form, you're just going to solve for those factors. We don't have to factor it. Some of the other reasons is because factoring is faster. It's a lot quicker most of the time. Where quadratic formula is really helpful is if we try to factor, so trying to find two numbers that multiply to this and add to that, and we say it's not possible. I can't come up with two numbers. Two reasons. One is that there are no possible values, but the other reason is that they might be non-integer numbers, fractions, decimals, things like that, and that's where the quadratic formula is going to help us. So to find the zeros of this expression in standard form, you can use the quadratic formula. You could also attempt to factor. So if I gave you a question like this first example, x squared plus 5x minus 14 equals 0, you can use the quadratic formula. Okay? You can always use the quadratic formula when it's a quadratic expression in standard form, but it's not always the best choice. We know how to factor this. This guy is a simple trinomial, so you're going to open up your two sets of brackets, and you're going to start each expression with x. That gives us the x squared when we FOIL it out, but you need two numbers that multiply to give us negative 14 and add to give us positive 5. It's not going to take you long to come up with positive 7 and negative 2. And then to solve, we set each bracket equal to 0 and just solve that equation, and we get our two zeros, or our x values, roots. So x is negative 7 or x is 2. If I use the quadratic formula, I'm going to get the exact same answers. So to use the quadratic formula, you need to identify a, b, and c. Now if we look up here, remembering that a is in front of our x squared term, b is in front of the x term, and c is always our constant. If one of those is missing, like if the x term is missing, or if your constant is missing, it's because there's a 0. The a will never be missing. We have to have that x squared for it to be quadratic. So in this particular instance, our a value is 1. Our b value is that middle term in front of the x squared, and our c value is the constant, happens to be a negative. Keep your eyes open for negatives in your equation. Don't forget them when you're pulling them out to put into the formula. So I'm going to fill in the blanks here, but you can just reference the formula at the top of the page. It tells you which letter goes where. So the equation is x is equal to negative b. So my b is actually a positive, but the formula tells me I have to make it negative. If my b was a negative, it's actually going to flip my sign. So you have to watch out for that, and that's why I specifically have this negative out front of the brackets. If I were to substitute a negative number in here, I'd have to multiply a negative 1 in, flipping my sign. Plus or minus b squared minus 4 times a times c, and the whole expression then gets divided by 2 times a. So we're just substituting in our b's, our a's, and our c. Simplify it all up. So that negative out front with my 5 makes that negative 5, plus or minus. Punch this guy into my calculator. So 5 squared minus 4 times 1 times negative 14. Punch it all in one shot, otherwise you have to be careful and you have to think about bed mass if you're going to do it in steps, but you should get positive 81. 2 times 1 on the bottom is just 2. So we're going to simplify up that root. negative 5 plus or minus 9, that's square root of 81, all over 2. Now you'll notice this guy in the middle, this plus or minus piece right here. Okay. He is there because there are two possible answers. I can either take negative 5 and add 9, then divide by 2, or I can take negative 5 and minus 9 and then divide it by 2. And that's going to give us our two roots, or our two zeros here. Negative 5 plus 9 is 4, divide by 2, or negative 5 minus 9 is negative 14, divided by 2, and I finish it off and I get x equals 2 or x equals negative 7. Sound familiar? It should. Which way would you rather do for this question? I think it's kind of obvious. Okay, so there is a place for quadratic formula. I wouldn't say this is the place, but it will work. There we go. So popping over to the next page, there are 4 questions here where you can try the quadratic formula and practice substituting in, remembering your a is in front of your x squared, your b is in front of your x, and your c is your constant. If one of those terms is missing, your x squared term, your x, where's my constant? That number's missing for a reason. It's a 0. So there's your hint for that one. So take a minute, pause this video, try those 4 on your own, and then I'll put the 4 solutions up so you can check your work. So do that now. Good luck. Alright guys, I hope that went well. You might have noticed a few little bumps along the way, or hopefully you did. So here's the first 2 for you. So they were pretty straightforward, substituting in. You'll notice this first one, taking the square root of 344, you do get a decimal number. So rounding to 2 decimal places is what I've done. 1 or 2 decimal places is usually reasonable, but make sure if it's an assessment, you just check the instructions to see what's expected for rounding. So when I simplify this up here, I get negative 0.05 for my first x-intercept and 3.655 for my second solution here. Over on the right-hand side, I get these nice numbers. I've got x equals 0 and x equals 6. That tells me that I probably should have just factored this. Now, it did ask you to use the quadratic formula, so you could practice this, but I just want to show you, if we come back up to this initial equation here, if I common factored out a negative 5x, I'd be left with x minus 6 equals 0. Pull this out, solve each one equal to 0, and you've got the same answer. You'll have x equals 0 and x equals 6. And that would have saved you doing all of that work. If you were given the option to just find this, like solve any way you wanted, would have been much quicker to factor it. Okay, so coming down to the bottom part of the page, I've got these 2 here. These are unique situations. So this particular quadratic, if I were to graph it, the parabola would not cross the x-axis. And I know that when I get down to this step, because the number under the square root symbol is a negative, it is impossible to take the square root of a negative number. No number, when you multiply it by its identical self, will result in a negative value. So, for example, we think negative 2 times negative 2. The same number, when we multiply, we always get a positive. If you multiply positives together, you get positive. You multiply negatives together, you get negative. The only way to result with a negative is if one's positive, one's negative, and then they can't be identical. So if you get that negative under the square root, that means it's not possible and there is no solution to this quadratic. Okay? Coming over to number 4, works out fine, everything works out nice. You might have noticed you get the exact same answer twice because we got that 0 under the square root symbol. So these are our 2 special scenarios. If we get that negative number under the square root, there is no solution. If we get the 0 under the square root, there is one possible solution. So we see the same answer twice. It means that there is one root, or 1, 0. Okay, x equals 3. Now this one as well, you'll notice we did get nice values. X equals 3 is a nice one, which means this guy was pretty simply factorable. It's a simple trinomial. So if you just go ahead and solve that as a simple trinomial, it would save you doing all those steps in the quadratic formula. So that is it. The key message is quadratic formula works every time as long as you follow the steps and follow your BEDMAS and watch out for negatives. It will always work for you, but there are instances where factoring is more appropriate and a lot quicker, and it's going to save you time when you're rushing as the bell's about to ring on that unit test. So that's it for today. See you guys tomorrow.